Design and development of fire extinguisher. Action robot, F.E.A.R. Abstract. The aim of this paper is to discuss the design and prototyping of a reconnaissance-type fireproof rescue robot, codename F.E.A.R, for detecting and extinguishing fire. In recent years there has been a surge in usage of unmanned ground vehicle, UGV, technology, but even with current technological advances, very few platforms have been created that aim to provide RC robots that can be inserted into high-risk areas at a low cost for extended periods of time. The robot is designed and fabricated to enter the core region of fire, extinguish it and provide a live feed from incident area by using a camera to increase knowledge about fire behavior. This will reduce the risk of injury and number of casualties for firefighters as well as for possible victims. The robot also decreases the monetary losses, which increases considerably as fire duration increases. The user can achieve controllable motion by a suitable tethered, ground-based remote control interface to control a multi-purpose robot that can be used in extreme terrain, and can douse different classes of fires. The prototype robot is maneuvered with the help of 4 geared motors, each attached to one wheel, and its movement will be controlled using Bluetooth remote control, where the transmitter will be a smartphone. Keywords: Bluetooth-controlled robot, firefighting robot, geared and servo motor, Creo, ANSI. Introduction. There are basically 4 components that are required to start and sustain a fire or flame. They consist of fuel, heat, and oxygen, which together undergo a chemical reaction to form fire. By taking away any of these 4 elements, a fire can be extinguished. The F.E.A.R prototype is designed such a way that it can carry up to 1.5 liters of an extinguishing agent, EA, in a closed chamber. With the help of mini-pump, the extinguishing agent is sprayed precisely from the nozzle, which creates a mist at the target location. This reduces the amount of extinguishing agent required to douse the flame, which decreases the time required. It is also outfitted with a camera to provide live feedback of the affected area to the operator. F.E.A.R will automate dangerous tasks of firefighters, allowing them to focus more on saving victims. 2 objectives. Since the robots available in the market are currently limited by their high initial and maintenance cost, an alternative low-cost product is necessary. With the view of the above scenario, the current work focuses on the research and development of a robot spraying platform powered by 4 motorized wheels. Remote operation of the robot platform is achieved by the user through a suitable interface. Our objectives are as follows: to perform reconnaissance duties and thereby reduce the workload of a manual firefighter. To traverse areas that cannot be easily accessed manually. The robot can directly enter into the area of the source of a domestic fire burning at an approximate temperature of 800 degrees Celsius, 107 K. The robot can be used to analyze the spread of the fire, as it can stay in the region of fire for a prolonged period of time. 3 CAD modeling. 4 System overview. Fig. 6. System overview. From the proposed system overview given in Fig. 5, we can see that the robot is controlled by a smartphone running on an Android. Application. The robot's control unit is developed using Arduino Uno controller. It is equipped with a camera, a Bluetooth receiver, 2 servo motor, for controlling the direction of spraying, 1 pump motor, to spray the pesticide, a Li-ion battery, 3 2-channel relay boards, LED lights, an active cooling system, and 4 12V30 RPM DC motors. Each one of the first 2 relay boards commands the movement and direction of the robot, while the third controls the spraying of EA along with lighting. The Arduino solves the data received from the Bluetooth module sent by the Android phone application. The Android operating system has an application which allows the mobile's inbuilt gyroscopic sensor to control the movement in 4 directions: forward, backward, left and right, as instructed by the user. Hence, rotating the mobile phone in any particular directions results into the corresponding propulsion of the robot. There is also an option present within the for only direction control using arrows on the Android application. The directional control commands are communicated to the robot through Bluetooth, BT, communication via the BT module. Some characteristics of the Arduino board are: 1 digital I/O pins. These are numbers 0 to 13 on the Arduino board and is used to take input and output based on the software flashed and returns a 0 or 1 that is low or high signals. 2. Analog input signal. These are numbered A0 to A5 and are used to scan for analog signals from the sensors. 3. 3 Atmega 328. Arduino are built on the Atmels Atmega 328 microcontroller. This prevents overheating of electronics and system failure. The outer casing for the robot is made out of mild steel, which is known to have a melting point in the range of 1350 degrees Celsius to 1530 degrees Celsius. The robot is fireproofed using a ceramic fiber blanket which is able to withstand temperatures in excess of 800 degrees Celsius, and reduces the temperature to around 100 degrees Celsius to 150 degrees Celsius. The ceramic blanket is sandwiched between the mild steel plate and a mylar sheet that acts as a final defense barrier against the heat. Mylar is also known as BOPET, biaxially oriented polyethylene terephthalate, is a polymer film and acts as an insulating material which further decrease the temperature to around 30 degrees Celsius, which is the optimal temperature for electronics. These materials provide passive cooling that allows the robot to operate at a relatively cooler temperature compared to surroundings. Since the internal electronics generate heat during operation, an active cooling system, ACS, is provided which cools down the temperature to well below 15 degrees Celsius while venting out hot gases through the rear vents that might have leaked in. The ACS can work automatically or manually through the app, by taking real-time temperature measurements using a thermocouple present within the robot. V application. 1. The Android application that is used for controlling this robot is Bluetooth RC and is available on the Play Store. 2. The application connects to the HC05 Bluetooth module in the car and controlled either by the directional keys or the gyroscopic method. Fig 7. Controlling using directional keys. Fig 8. Controlling using gyroscopic method. 6. Conclusion. This paper has presented a unique vision of the concepts which are used in this particular field. As we can see, using an integrated system provides us with better product as it reduces weight and improves efficiency. It also provides greater flexibility to the robot and the user as a digital platform is used. Currently the robot is only able to extinguish Class A fires, but further work might provide us with a robot that can handle all classes of fires by employing a variety of techniques. In the near future, these robots may also be embedded with artificial intelligence technology which could help extinguish fires faster by running simulations and choosing the best method of action. Better materials may be available that could help to decrease the weight and size of the robot whilst also withstanding higher temperatures and allowing to be used in more extreme environments. Although we have tried to achieve most of the proposed framework and vision, a deeper and clearer understanding along with better R&D is required to fully visualize and implement through collaboration with various entities. 7. Acknowledgement. This work has been supported by Principal and Head of Department, Mechanical Engineering, JSS Academy of Technical Education, Bengaluru, and college faculty. We would also like to thank Project Coordinator Mrs. Rupa DN, Assistant Professor.